So I just wanted to add some extra remarks about the advantages of laser drones or photonic insecticides. And first of all is the cost per hectare. Now the cost per hectare in reality comes down to the battery uh, wear. That's the actual cost. That's the only thing that has a very big. That's the dominating factor, right? But currently, battery technology is improving um, quite fast. So, example, no, this is a flying hour. Oh, my apologies. Mm, where do I have here this section? So here you can see that actually the cost, if I take away the depreciation of the laser and drone, in reality, it's more of a theoretical thing, the depreciation of laser and drone, because if I this is now you have only battery, right? Battery and scouting scan. That's a real cost. But let me just do this away. And electricity is almost nothing. So if you just look at battery wear, then we can see that it's projected that we can beat the costs of chemical insecticides. Now, what is the cost in reality of depreciation? How much, you know, what is the maintenance cost of a drone? Well, if you take a big drone, something like this, a lot of people will say, well, it has a lot of maintenance cost. Why? Because you need specialized equipment to transport the drone. These pieces are big and things like that. So yes, this has significant cost. A lot of times, if you would own one of these drones, a specialized repair company would need to come to your farm and do the maintenance on this machine. That makes it um, expensive, right? So if you have a big machine, any big industrial machine in a farm, then people need to come to you and they need to work on that machine in non-ideal environments, right? They need to make improvised lifting equipment. It's dangerous. It can crush your hand, all kinds of stuff like that. But from the moment you go to a small machine, so I'm thinking more, this is a realistic machine, something like the DJI Mavic T3, something that weighs about a kilogram, which is sufficient to lift. This can for sure lift like 200-300 grams comfortably. Um, the big advantage of this in terms of maintenance is it's small, so you can ship it. So instead of somebody coming to you, what you do, you put this in a box and you ship it to a specialized factory, which cost maybe 20 euros in shipping cost. There, they have specialized equipment, special trained people, they have all the parts, they have the correct computer systems to analyze and diagnose any problems, do any calibration and stuff like that. So the big advantage that makes the price for maintaining a very complex machine very low because it's done in one region of the world and then you ship it back. So let's say total logistical cost is 40 euros plus maybe 50 euros the actual maintenance, of which most of that is actual profit, and 20 euros of parts. Because also what degrades of a flying drone? Well, the battery, that's the main component. But then if you look at the actual components of a small drone like this, then basically you're gonna have like brushed motors or things like that. You could say have wear and tear. And actually, it's not the motor itself; it's only the bearing inside the motor. But you can see that motors of this size, they cost around 10 euros. It's not the end of the world. Same is true for the electronical, like the ESPs, the thing that provides the power to this motor and things like that. These are not super expensive components. And this is actually the components that have the wear and tear, right? And then the other thing that will most likely destroy, has the most degrading effect on the drone is going to be sun, right? UV radiation eating up the plastic. That's something I see as realistic, but you can also fix that by putting a layer of aluminum or something on there. Um, or there are solutions for this kind of things. So that's why the maintenance cost of many small machines, such as drones flying, is going to be way, way, way less than a cart. Because a cart like this, even if you make the smallest cart you could possibly imagine, something like this, it's very hard to ship. So That means the specialist needs to come to you, and just that transporting a human is just way more, takes the time of that human, and therefore much more expensive. And then he comes there and he needs to work in a non-optimized environment. Uh, so that's why, and then also it needs to work on a machine that's likely specialized in this specific crop. But a drone is universal, it goes over all the crops, it doesn't care about interspacing and all that stuff. So that is why probably the total maintenance cost of a small machine such as a drone is way less, and also the cost of, and then the resulting cost per hectare is going to be dominated by the battery depreciation. Right, that's in an ideal world, and I think that is possible. So I just want to make that remark. So don't compare it to machines like this. Think of machines like this. That's the whole thing. So the whole name of the game is getting a very fast optical loop. So basically this tracking. This needs to be very high quality and very fast. If you get this very fast, then you can use a small low weight laser, and those also don't cost that much. So here is a 5 watt laser of the intended wavelength, which is, as you can see, around 250 euros. Maybe you need one, maybe you need two. That's how we design the machine. But these are, not expensive, not super expensive at least. Obviously, laser is much more expensive than a motor, than a brushless motor. But okay, just giving some numbers. So maybe we need one of these, but these go 10,000 hours. So this is for a lifetime normally. So if you make this loop very fast, then you don't need too much laser power. That means the optical unit can be made very small and also cheap. That means you can have a small drone. That means maintenance cost gets very low because you can send it to a specialized factory. That means the actual dominating cost per hectare factor becomes the wear and tear on a battery, which you can just calculate and which is going to drop in the coming years because the majority of the world is looking into improving battery technology. And now also I want to give a little realism, like how small can we make, how lightweight can an optical unit with a MEMS mirror be made? Well, here is an example of, well, they launched at some point in time, don't know exactly when, but like in 2015 or something, they launched they tried to launch some smartphone, for example, the Blackview Max 1, which has internally a MEMS projector inside it. Now that's an optical unit that gets very close to the unit that will be required for shooting the Colorado beetle or other target insect. And here you can see it there down. So you can see it's this small, probably aluminum shell component, aluminum mounting piece with, in this case, we have three small laser diodes. Then we have a combining crystal, so all of these outputs of the light go in that direction. And this is the MEMS mirror. This is actually where there is a very tiny mirror that moves very fast. And you can see that this whole, the MEMS mirror is maybe 1-2 grams. And then the whole optical unit is, I haven't weighed it, but let's say 30 grams. So basically, if you take this and you add a camera here, so that can see onto which the MEMS mirror is currently pointing, and so it can see that and it can correct the MEMS mirror so it's pointing exactly at where you want to be pointing, so at the head of a beetle or something. Then that's basically it. So basically all you need is here, you put an extra, is a little camera, and then you have a chip, and that's a realistic optical unit. So it's like a flying matchbox. About that's going to be its size. And here is, for example, this optical unit. Let's we can maybe see the mirror here. Let me try and find the mirror. Yeah, so here is the actual mirror, right? That's it. See that little thing there? This is the MEMS mirror, right? And the fact that this phone, so complete smartphone, including the full projector and MEMS mirror in there, costs around 400 euros, gives you an idea of the price of this kind of technology. So if you build this on well-designed industrial scale, this does not need to cost 10,000 euros, right? So we just add this. These of course are quite low power lasers. We add this laser, and then little camera processing. So this gives you a more realistic view. Otherwise, you start to think of big machines, but you can make it very small. That's kind of, at least I think so, and that's kind of the whole idea. Once you can do that, then this loop becomes possible. And then you have a lightweight drone, and then because it's a lightweight drone, maintenance gets very low, is restricted to battery, and then you have a very low cost per hectare. Also a very robust system, that it does not care about like if there is sun, is there is no sun, if the soil is wet or not, it doesn't get stuck. Um, Very easy. You can very easily sell it and pass it on to other farmers. Um, so I think that's then a very useful commodity device for farming. That would be the big vision. And then also I want to quickly address some advantages also of well, there are some additional, there's some noise, sorry. So I think I've put also a section that using this could unlock some additional monetary compensations. For example, uh, basically you're going to be more bio, right? So well, you're going to have less soil compaction. So that alone should give you, this is kind of scientifically proven. Scientifically speak, around numbers of 20 euros per hectare that you get in extra profit just by compacting the soil less, and you have less damage to the plants, because every time branches of potato plants snap off, they increase the chances of fungal infection and things like that. So by just taking more care of your soil and plants, you have a little bit of extra gain. Not too much, but something. 20 let's say 20 euros per hectare. Then if you use less chemicals, then you're gonna have unlock some kind of ecological schemes that the European Union has in place, which is a realistic number, around 400 euros per hectare. So that's actually a big number, right? Um, and then you have some other obvious benefits, is that it's resistance proof, because right now every 2-3 years they need to make a new research new insecticides against Colorado beetle, and one such episode costs around 300 million euros, right? So if you have a laser drone or there is no resistance, you have no bikill. So because you're not spraying anything, it only kills Colorado beetles. That means you keep the natural enemies, um, like ladybugs and stuff that eat the eggs of the Colorado beetle and the other pest insects, and that means you keep the natural balance much easier. So you're working with nature against, so but slightly tipping it in your favor, versus completely wiping out the natural predators. Uh, yeah, there is no chemical exposure to the farmer, because they also don't like these chemicals in the end, or children nearby and playing stuff like that. There is no water contamination. There is no drift, because if you want to spray with drones, you do have to wait until it's wind still. And I've heard, this is not scientifically proven, but I've heard from farmers um, that well, only for one farmer, so this is completely not scientifically, but it hints to a reality, that they need to wait until night time, because at night time you have less wind, and it's less wind, so they spray then, which is annoying, because they need to stay up to wait for spraying. Yes, so that's, and they cannot spray, of course, around kindergartens or anything like that. So you're also weather dependent. It's not weather dependent. If you use, for example, if you're gonna spread nematodes, which is a biological control, which costs around 300 euros per hectare. Okay, but there's a very very little worms in water, right? Tiny worms, and they're sensitive to UV. So basically, you cannot spray during the day when you have a lot of sunlight, because it's gonna kill all your micro worms. So you need to spray more until the end of the evening. But at the end of the evening, basically these plants, potato plants, are alive, and at the end of the evening, their leaves are oriented more upwards. This is how a plant goes to like to sleep, let's say. Um, and because of that, you're not gonna have good coverage of the full leaf surface, which means that actually uh, quite some beetles will survive. And if you spray, independent if you spray with biological means or chemical means, I know this from an agronomist. He told me that in any spraying solution, um, like between 15% to 30% of your target insect will survive, right? So you always have. So you cannot say like, well, with the laser drone you're not going to be able to kill them all because some will be hidden. Well, yeah, but that's also true for any chemical control. And then also, very likely, if you do the calculations, making uh, pesticides is actually is quite CO2 intensive. Because it requires you to make steam and to power the chemical things. And then you also have the transportation and you have the delivery. The whole chain is quite, creates quite some carbon. And then also when the chemical insecticides reaches the soil, it actually kills some of the biosphere in that soil, and that actually again releases CO2. Um, and this is quite substantial actually. This has a substantial effect on the total green gas emission, things like that. So likely also flying with a drone, because you're not hauling a big piece of metal. You're transporting basically a very tiny amount of matter that is flying. The whole consumption, the total chain of used energy and emitted carbon um, is much smaller. So this is a side effect as well. So okay, these are the extra things I just wanted to remark. So basically, the why not a big card? Well, maintenance is much smaller for a small device. That's a big advantage. And then the advantage itself of laser drones is no resistance, no particle, and so forth.